Hello everyone, this is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please do not forget to like, share, subscribe. Please subscribe and share my video. Please, God will bless you. Thank you. For partnership, this is my OPay account number so that we can be able to reach more audience all over the world. And this is my phone number. This is my email account, sharegorekoya@gmail.com. My OPay account is 81413645573. Thank you so much. Now, today we are going to, carry out exercise on polynomial. The first question I'm going to solve is that given polynomial f of x is equal to x cubed plus 2x squared minus 3x minus 6. The question says find f of 0, and the second one f of half. Then the next one says find the factors, the roots, and another one is sketch the graph. Sketch its graph. So this question I have here has actually covered the question C I have here. So this one can be taken as an assignment for you. So now we are given this expression. We are asked to find f of 0 and f of half. F of 0 simply means when your x is 0. F of half simply means when your x is half. What I'm going to do is this. In order not to take much of our time, okay, let me solve the two. So let's start with when x is equal to 0. Then f of 0 will be 0 raised to power 3 plus 2 times 0 raised to power 2 minus 3 times 0 minus 6. 0 raised to power anything is 0. Everything here is 0. Everything here will be 0. So you are left with minus 6. So that means f of 0 is minus 6. What this one is saying is that when the value of your, because f of x is on the y-axis in Cartesian coordinate system, f of x is on the y-axis. So this question is talking about when the value of your y is minus 6, the value of your x is 0. So when the value of your y is minus 6, because f of 0 is equal to minus 6, f of x. So then the value of your x is equal to 0. So it's mentioning these particular points. That's the meaning. And then the value of our x are on the horizontal axis. The value of our y is on the vertical axis. So that's what this one is talking about. Then for this one, it's saying that when the value of f of half, we are talking about f of half now. What will be the value of f of half? That means when your x is half. Let me quickly do that on this side of the board. Let's see what we are going to get using f of half. So f of half simply means anywhere you see x, you put half there. So I am going to start it with f of half. F of half is equal to 1 over 2 raised to power 3 plus 2 times 1 over 2 raised to power 2 minus 3 times 1 over 2, then minus 6. Now, using law of indices, I have half raised to power 3 means half times half times half. So it's going to be 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. Here, half raised to power 2 means half times half, that's 1 over 4 times 2. So I have 2 times 1 all over 4. Minus 3 times half, that is 3 all over 2. Then minus 6. So here, I'm going to have 1 over 8. Then plus 2 in 4 give us 2. So that is 1 over 2. Minus 3 all over 2. Minus 6 all over 1. So if you look at this, the SCN here is 8. 8 in 8, 1. 1 times 1, 1. Plus 2 in 8, 4. 4 times 1, 4. Minus 2 in 8, 4. 4 times 3, 12. minus 1 in 8, 6. 8 times 6 is 48. 48. So what I have here now is 1 plus 4, that is 5. 5 minus 12, that will give us minus 7. So I'm going to have minus 7 minus 48 divided by 8. So minus 7 minus 48 will give us 7 plus 8, that's 15. That's minus 55. Minus 55 divided by 8. So what this one is saying is that when the value of my x is half, the value of my y is minus 55 all over 8. And then, 8 in 55 will give us we have minus. So 8 in 55 is 6 whole number. In 55, 6 whole number, that's I think 7 over 8. So the value of my y will be somewhere here. So that is minus 6 whole number, 7 all over 8. When you trace it to this y, this is what the point will be on the Cartesian coordinate system. So that's for that. Now the question says we should find the factors, the roots, and sketch the graph of this polynomial up there. So what do we do? This is why we are going to do it. We are going to use a remainder theorem to establish the root. So let me remove this. I've already done this, so we don't need it here. So how do we find the root? Because this polynomial is raised to power of 3. The polynomial will have 3 factors. If a polynomial is raised to power n, it will have n numbers of factors. If a polynomial is raised to power 2, it will have 2 number of factors, like a quadratic equation. It's a trinomial polynomial, which has the degree of 2. Therefore, the number of factors for quadratic expression will be 2. So for this expression I have, the number of factors is 3. Now, the factors, so this quadratic, this polynomial now can be put in a factorized form by putting 3 factors. But we don't know what this factor, the shape this factor will take. So each of the factors will have x, x, x. So that when you multiply x times x times x, you have x cubed. So the other parameter that go with this x, we don't know it. Let's say it's either plus or minus a, either plus or minus b, either plus or minus c. Now the next thing is this. The multiplication of this parameter I have here, a, b, c, must give me a factor of 6. So severally, I can have 2 times 3 times 1, give me 6. I can have 1 times 6 times 1, give me 6. So this parameter a, b, c can take any of these values of factors. Can take a factor of 1, can take a factor of 2, can take a factor of 3, and can take a factor of 6. So we don't know which of them to pick. So what this thing is saying is that if for a, if I'm taking 1 for a, that means I'm going to consider s plus or minus 1. If I'm taking a as my 2, I'm going to consider s plus or minus 2. If I'm taking a as my 3, I'm going to consider s plus or minus 3. If I'm taking a as my 6, I'm going to consider s plus or minus 6 as my factor. The same thing is applicable to this and this. But the moment we have been able to get the factors using either of these that satisfy the remainder theorem, then we don't need to test for this. We use what is called long division method. Now, let's do our testing here. Let me test for where my a is 1. So let's test for x plus or minus a. Let's say I'm testing for x plus or minus 1. So that means I'm having 2 factors here to be considered. Let me consider x plus or 1 first. then I will consider x minus 1 and see which of them will give us remainder 0. Now you set, like I said the other time, you set each of these to 0 to 0, 0. So let's start with this first one. So it means I'm going to test when x is minus 1. Here I'm going to also test when x is plus 1. Let's start with when x is minus 1 here. So I have f of minus 1 is equal to minus 1 raised to power 3 plus 2 times minus 1 raised to power 2 then minus 3 times minus 1 minus 6. Here, this is the whole power, so I'm going to have negative 1. Here, this is an even number, it's going to be positive. Plus times plus give me plus. 2 times 1 will give me 2. Minus times minus will give me plus. 3 times 1 will give me 3. Minus 6. Now here, 2 plus 3, that's 6 minus 6, 0. So my remainder here is minus 1. So that means this particular factor that gave us finding minus 1 is not a factor. Now let's test for this one when x is positive. So that means f of 1, this method we are doing is called trial by trial method. So let's test for when s is 1 in this function. So I have 1 raised to power 3 plus 2 times 1 raised to power 2 minus 3 times 1 minus 6. So 1 raised to power 3 give me 1 plus 2 times 1 give me 2 minus 3 minus 6. You see, this one will not give me 0. 1 plus 2 is 3. 3 minus 3 is 0. So I'm going to have minus 6. That means these two factors are not factors of this expression because I'm not having remainder 0. So we now move and try for 2 now. So by trial and error, I do not want to waste my time. You can start with when x is plus 2. So what I'm trying to say is that when my a is 2, so I'm going to try, when my a is 2, I'm going to try x plus or minus 2. But let me even try x minus 2 factor first. X minus 2 and see. So if I'm picking x minus 2, you set it to 0. So your x is equal to 2. So we are going to test when x is 2 in this function, polynomial function. So we have s into bracket 2 is equal to 2 raised to power 3 plus 2 times 2 raised to power 2 minus 3 times 2 minus 6. 2 raised to power 3 here is give me 8. 2 raised to power 2 here, that is 4 times 2, will give me 8. Minus 3 times 2 will give me minus 6, then minus 6. So 8 plus 8 give me 16 minus 12. So this does not give me what I'm looking for. 16 minus 12 will give me 4. So I'm not having 0. Now let me go and test for x plus 2 as a factor here. I already tested for x minus 2. I did not get remainder 0. So let me test for x plus 2. So in this case, this will make me to set it to 0. I'm talking about x plus 2. So if I set this to 0, then I'm going to test x is equal to minus 2. Now we put minus 2 anywhere we see x there. So I have x into minus 2 is equal to minus 2 raised to power 3 plus 2 brackets minus 2 square minus 3 brackets minus 2 minus 6. Now this is odd power, so I'm going to have negative as my answer. So what I have here now, 2 raised to power 3 give me 8. So this is 8. Even power will give me positive. Plus times plus will give me plus. 2 raised to power 2 is 4. 4 times 2 will give me 8. Minus 3 times minus 2 will give me plus 6. Then minus 6. Everything is equal to 0. Therefore, you say s plus 2 is a factor of the polynomial f of x above. So s plus 2 is a factor of this polynomial. The moment you have tested, you can equally go ahead and test for each of these factors here and see which of them will give you 0. But it will take a longer time. The moment you have established one of them, you can use that one to generate the other factors using what is called long division method. Now, let's do the long division for this now. So we have established that the factor here is s plus 2. So we are going to use s plus 2 to divide this polynomial. So what we are trying to say is that we want to get s cubed plus 2x squared minus 3x minus 6 divided by x plus 2. So what we have on top here is called dividend. What we have down here is called divisor. Please take note of that. So using long division, I can rewrite this like this, putting my divisor outside here. Then my quotient will normally be located here. Then my dividend, which is my polynomial, is here. Then our remainder is here. This is the arrangement of what our procedure, the skeletal form of the procedure of our work will look like. The quotient is normally located on top here. The divisor is normally located here. The dividend is here. Then the head of our workings will give us the remainder. So take note of this skeletal, frame of work. Now, let's proceed. So, I will rewrite this now like this. X plus 2 dividing s cubed plus 2s squared minus 3x minus 6. So what you are going to do now is to use this to divide this term. So that means s cubed divided by x. This is the line of work. Give me s squared. So the s squared that you get, put it on top here. Use the two of them to multiply this s squared. X times s squared will give me s cubed. Plus 2 times s squared will give me plus 2s squared. So the next thing you are going to do is to subtract. So when you subtract here, give me 0, this will give me 0. Bring the next term down, which is minus 3x. Again, use this x to divide this minus 3x. Say minus 3x divided by x. That will give me minus 3. So you are going to have minus 3 here. Then use these two now to multiply this. X times minus 3, that will give me minus 3x. Plus 2 times minus 3 give me minus 6. So what you now do is to subtract. When you subtract, let me do the operation again. There must be a mistake somewhere there. Sorry about that. So I'll write x plus 2 dividing s cubed plus 2s squared minus 3x minus 6. So the operation is, use this to divide the first term here. S cubed divided by x. That will give me s squared. Put the s squared there. Use each of these to multiply. X times s squared will give me s cubed. Plus 2 times s squared will give me plus 2s squared. After we have done that, subtract. When you subtract, we have 0, we have 0. Bring the next one down, that's minus 3x. Use this s to divide minus 3x. We have minus 3x divided by x. That will give me minus 3. So you write this minus 3 there. Use these two to multiply this minus 3. X times minus will give me minus 3x. Plus 2 times minus will give me minus 6. Then we subtract. When you subtract, this will become plus. This will become a plus. So what we have here now, this minus, that has become plus. So plus 6 minus 6 give me 0. So this is the other factor of this expression that we have here. So that means x plus 2 times x squared minus 3. They are the factors of this expression. Now, how do we now, the question says we should sketch the graph. So for you to sketch the graph, get the points on the x-axis and on the y-axis. This is the y-axis or f of x-axis, and on the x-axis. So the value of the function, the value of the roots when the function is 0 is what we want to get now. So you say when the function is 0, it's either this is equal to 0 or the other one is equal to 0. So you say x plus 2 is equal to 0, or x squared minus 3 is equal to 0. So here my x is minus 2. So that means you have the value of x as minus 2 here. Here now, x squared, take this minus to the other side, become plus 3. So x will be plus or minus square root of 3. Square root of 3 is more or less plus or minus 1 point something. So in a nutshell, I'm going to, when I have 1 here, the square root of 3 will be somewhere here. Square root of 3 will be somewhere here. So if I want to sketch the graph now, I want to look at the value of my f of x when x is 0. When x is 0, put 0 there. We have 0 plus 2 times 0 squared minus 3. So 2 plus 1, 2 times minus 3. That's minus 6. So that means when x is 0, my y is minus 6. So to sketch the graph now, the graph will pass through, we are having two of these. The graph coincide at those 2 points. So the graph is actually going like this, passing through this side and passing through this side, but it's meeting this place at the same point there. So that's the procedure of sketching of the graph. Now, the next question that we are having is, given that x plus 1, the question says given that x plus 1 and x minus 2 are factors. That means are factors of s cubed plus p s squared plus qx minus 6. Find p and q and factorize the expression. Factorize the expression. Look at the equation very well. Given that x plus 1 and x minus 2 are factors of this polynomial function, we have to find the value of the unknown p and q, and also factorize this polynomial function after we have gotten the value for p and q. Now, what I'm going to do now is that if x plus 1 is a factor, if x plus 1 is equal to factor, then I can set my x plus 1 to be equal to 0. Therefore, x will be minus 1. So that means anywhere I see x, I put a minus 1. And everything will result in remainder of 0. So I will now write here now. Let me write this function as f of x. is equal to s cubed plus p s squared plus qx minus 6. So when my x is minus 1, I put minus 1 anywhere I see x. So I have f of minus 1 is equal to minus 1 raised to power 3 plus p times minus 1 squared plus q times minus 1 then minus 6. Everything must be equal to 0. So minus 1 cube here will give me minus 1. Minus 1 square will give me 1 because this is even power. So plus times plus, that is plus p. Plus p. Minus times plus minus q times 1 q minus 6 is equal to 0. I can rearrange this equation as p minus q minus 1 minus 6 is minus 7 is equal to 0. I can take minus 7 to that side. So p minus q is equal to 7. This is equation 1. So the next one we are going to do is when x minus 2 is a factor. When x minus 2 is a factor. When x minus 2 is a factor. Then set x minus 2 to be equal to 0. Then we are going to carry minus 2 to that side. We are going to test for when x is 2. Now let me test for when x is 2 here because of the space on the board. So anywhere you see x, put 2. So we are having f of 2 is equal to 2 raised to power 3 plus p times 2 raised to power 2 plus q times 2 minus 6. So 2 raised to power 3 will give me 8. 2 squared is 4. 4 times p will give me plus 4p. 2 times q will give me plus 2q. Then minus 6. Everything must be equal to 0. So now we collect like terms here. 4p plus 2q we stand on one side of the equation. 4p plus 2q. Then I have 8 minus 6. 8 minus 6 give me plus 2. When I carry plus 2 to that side, give me minus 2. So this is my equation 2. Let's look at it again. When x is 2, you put 2 anywhere you see x here. 2 raised to power 3, 2. 2 square 4p. Then 2q minus 6. 8 minus 6 give me 2. So I have here. Now if you can see, I can divide this equation through to make it simpler. I can divide this equation through by 2. If I divide this equation through by 2, this will give me 2p. Give me, if I divide this equation by 2, I'm going to have 2p plus q is equal to, divided by 2, give me minus 1. Let's call this one equation 2. So I'm going to solve these two equations now. So let me clean the board for space. Since I've gotten the equation I want to solve for p and q. So I want to solve, let me write those two equations. Equation p minus q is equal to 7, equation 1. Then equation 2p plus q is equal to minus 1. That's equation 2. By elimination method, add these two equations together here. Plus q minus q give us 0. So we're having 2p plus p. That's 3p. Here, 7 minus 1, that's 6. Dividing both sides by 3, p is equal to 2. Since I've gotten my p to be 2, I can substitute in equation 1 or 2 to get my q. Let me substitute in equation 1. So anywhere I see p, I put 2. So it's going to be 2 minus q is equal to 7. So I want to make my q to be positive, carrying it to this other side. Then plus 7 to that side become minus 7, 2 minus 7. So this one become minus 5 is equal to q. So I've gotten my p and q to be 2 and minus 5 respectively. So I'm going to put them back into this original equation. So my polynomial f of x now will now take this shape. S cube, my p now is 2. Put 2 there. That's a plus 2s squared. My q is negative 5. Put minus 5 there. Minus 5x minus 6. So this particular equation is what I want to factorize. And I've taught us this procedure for factorization. Now, let me clean up this place since I've gotten my polynomial function after obtaining the value for my p and q. So to factorize this polynomial function, I look at this this particular constant term. I'm going to find the factor for 6. Factor for 6 is 6 times 1. Then I can have 3 times 2. So all the factors for 6 are 1, 2, 3, and 6 itself. These are the collection of the factors of 6. So what I'm going to do now, I will now use trial and error to get my factor using the remainder theorem. So since this particular polynomial is to the degree 3, it's going to have 3 factors. So the factors will take this shape that I indicated the other time: x plus or minus a, x plus or minus b, x plus or minus c. So I will try each of these factors when a is 1. Let me start with this. When a is 1, I can try x plus or minus 1, which imply x plus 1 or x minus 1. If I'm picking x plus 1, I will set it to 0. Set it to 0. Therefore, x is minus 1. So let me now test when x is minus 1 here. F of minus 1 is equal to minus 1 cube plus 2 times minus 1 square minus 5 times minus 1 minus 6. So minus 1 cube, this is odd power. You give me minus 1. Minus 1 raised to power 2, this is even number, give me positive. That's going to be plus 2 times 1, that's 2. Minus times minus, that is plus. 5 times 1, that is 5, minus 6. 5 plus 2, 7. Minus 6 minus 1, that's minus 7. Minus 7 plus 7 give me 0. Therefore, this particular factor I have is a factor of the polynomial. So I've obtained my factor. So one of the factors of this polynomial is x plus 1. I do not want to waste time testing x minus 1. It's not going, since this one has given me, this one will never give me. And I can equally do trial and error for the other factor, 2 or 3 for this b, or 6 too. We can still generate, but it will take longer time. Since I've obtained one of the factors, I will now use what is called long division method to get the other factors out. So what I'm going to do now is to use this factor to divide this polynomial function. So I have x plus 1 long division method. I put this one inside here, s cubed plus 2s squared minus 5x minus 6. So here now, we use this first term to divide. That is s cubed divided by x, give me s squared. So you put s squared here. Use these two to multiply. X times s squared, you give me s cubed. Plus 1 times s squared, will give me plus x squared. So after that, you do subtraction. Please don't forget. When you subtract, this gives you 0. This minus times plus give you minus. 2s squared minus s squared will give me s squared. After you have done the subtraction, bring the next term down, minus 5x. Again, repeat the process. Use this x to divide. Use this x to divide what I have here. So x in x squared will give me, look at this s squared divided by x will give me x. So I put plus x there. So I will use these two now to multiply this x. X times x will give me s squared plus 1 times x will give me plus x. So we do subtraction. Now, when you put minus here, this becomes 0. This will become minus. So this becomes minus x. Minus 5x minus x, that's minus 6x. Then I bring the next term there. Use the process to divide 2. X in minus 6x will give me minus 6. After you have done that, use this 2 to multiply minus 6. X times minus 6 give me minus 6x. Plus 1 times minus give me minus 6. Then we subtract. When we subtract, everything gives us remainder 0. So that means this x plus 1 and this x squared plus x minus 6, they are factors of this polynomial function. Now, this particular factor here is a quadratic factor. We may or we may not be able to simplify, but let's try whether this can be easily factorized so that we can have the other two factors that combine to give us this, so that I can have the 3 factors out. Now, let me now factorize these quadratic factors out. I have x squared plus x minus 6. Think of two numbers that when you multiply them give you minus 6. When you add them together give you plus. If I consider 3 and 2, this coefficient here, sorry, give you the plus 1. When you multiply give you minus 6. If I look at this very well, I can have plus 3 times minus 2. If I add them together, it will give me the coefficient 1 here. So I will put them there now. Instead of the coefficient 1, I put plus 3 and minus 2. So I'll write plus bracket 3 minus 2x, then minus 6. So if I open these brackets now for this coefficient here, I'm going to have x squared plus multiply. That's 3x minus 2x minus 6. Then we know that these are like terms. I can factorize x out. So I have x bracket x plus 3. If you look at this place too, whatever you have here is better. You just repeat it, x plus 3. What do you put outside when you multiply give you this? It's minus 2. So we have this minus 2. So in a nutshell, you can factorize x plus 3 out here. That is x plus 3, leaving x, leaving out minus 2. So these are the factors of this. So the combination of this factor together with what I have gotten here give us this factor. So the factor we are looking for now are x plus 1 times these factors, x plus 3 and x minus 2. They are the factor of the polynomial f of x. Now, if the question says we should sketch the graph of this polynomial, so I've already factorized the expression completely. But if the question says we should sketch the graph of this polynomial, to sketch the graph of that polynomial, for f of x, we have obtained the factors as x plus 1 times x plus 3 times x minus 2. To sketch the graph, set each of these factors to 0. So you just say x plus 1 is equal to 0, which implies x is equal to minus 1 on the x-axis. Set this to be equal to 0. X plus 3 is equal to 0, which implies x is equal to minus 3 on the x-axis. Set this to be equal to 0. When you carry minus 2 there, it becomes positive. So it implies that your x is equal to 2. So on my x-axis, I'm going to have 0 there. This is f of x on the vertical. So my x are 2, minus 1 and 3. So this is the x-axis. So I have 2 here. Minus 1 will be here. And minus 3 will be on the other side. So what I'm going to do now is to sketch the graph of this polynomial function. What I will do is that the graph will definitely pass through each of these points on the x-axis. So you know that between minus 1 and minus 3, we have minus 2 there. So I want to check where the f of x will lie. Is it up or down between this minus 3 and minus 2 when x is minus 2? So let's test when x is minus 2. When x is minus 2, according to what I have here, I have minus 2 plus 1 times minus 2 plus 3 times minus 2 minus 2. So minus 2 plus 1 will give us minus 1 times minus 2 plus 3 give us 1 times minus 2 give us plus 4. So everything multiplied will give me minus 4. So that means when my x is minus 2 here, my polynomial function will be minus 4. So I have the graph will pass through this way down instead of up between these 2 points. Then I want to consider between these points of origin and 1 here. So because it's not an whole number, I may just check that idea for now. So let me now think about between 0 and 2. Between 0 and 2 is 1. So I want to know where my f of x will lie. Is it up or down between 0 and 2? By putting x to be 1. So when we put x to be 1 here, we have 1 plus 1, 2, 1 plus 3, 4, 1 minus 2, minus 1. 2 times 4, 8 times, that is minus 8. So that means my polynomial function will be down here also. So in a nutshell, if I'm sketching my polynomial function, if we go through these points like this, go through these points like that, then go through these points down here like this, and go through these points here like that. So this is the sketch of the polynomial f of x concerning this problem. I believe that you must have learned one or two things on the concept of a polynomial, the remainder theorem, the factors theorem, how to find the unknown if the factors are given. This is once again Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please do not forget to like, subscribe, share my YouTube video, please. And for partnership, this is my OPay number 814-1364573. The essence of this partnership is to improve on this video and to reach many people all over the world. Thank you. Have a nice day. Bye.